Hello everyone, welcome to SimpliCode's YouTube channel. I hope you guys are doing good and staying safe. In today's session, we'll be discussing some operations performed on doubly linked lists like insertion and deletion. Now, the operations of insertion and deletion can be done at various positions like at the beginning of the node, at the specific position, and at the end of the node. Now, in C++, a doubly linked list is similar to that of a linked list, except that each node also contains a pointer to the node preceding the current one. This means that we can travel not only in a forward way but also in backwards in doubly linked list in C++, which is not possible with a single linked list in C++. So in this tutorial, we'll be understanding the two main operations, which is insertion and deletion. If you want to learn more about what linked lists are, its types of linked list, and in detail about what doubly linked list is, we have a dedicated videos on our channel. So you make sure you check that out. So without any further ado, let's get started with today's session. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started. Let's now directly jump into Visual Studio Code for execution. So as you can see, Visual Studio Code has started. So let us just implement our code. So I'm just writing in the commands what we're implementing. It is, we are trying to implement doubly linked list insertion operations. Insertion operations. Now this can be done at the front of the list or at a specific position and at the end of the list as well. So I hope you've cleared with this. So let's just get started with the code here. So include the header files, #include iostream, and using namespace std. Now we have to create a structure for a doubly linked list, that is by creating a node. So the code for that would be struct node, and inside that we have to create the data variable, the pointer to the previous node as well as the next node. So int data and a node pointing to the previous, and similarly a node to the next. So I hope you're clear with this. Now we have to create a class for the doubly linked list. So for that I am taking a class. So firstly we are creating a new node and allocating some memory for it, and then we are assigning the values to the data members of the new node. So for that we are creating a class here. So let us take the class as class doubly linked list, and inside that I am giving a private member function, and inside that we are initializing the node for the head and tail. So node head and tail. Alright, and then I'm creating a public class where we are trying to create a constructor to initialize the head and tail pointers here. So we have to set the previous and next pointers of the new node to null here first. So that is the use case. So let's just write that. So doubly linked list is the class we have taken, and inside that head will be initialized to null, right? And tail will also be initialized to null. Alright. Now we have to create a function or say a method to add a node to the front of the list here. So next we have to determine the location where we want to insert the new node. Now it can be at the beginning, it can be at the end, or it can be at a specific position. So let's say if you're trying to insert at the beginning of the list, now the algorithm or the use case of it would be we have to set the previous pointer of the current head node to point to the new node, and then we have to set the next pointer of the new node to point to the current head node, and finally we have to set head pointer to the new node. So I'll just explain it when we are writing the code here, so you'll get a clear picture of it. So let us create a function, void, let's take the function name as insert at beginning, where it will insert all the values at the beginning of our node, and inside that I'm passing a argument of int data. So this is for creating a new node and sets its data to pass the value. So firstly, we have to initialize the node. So for that, I'm taking node, and a new node is equals to new node. Now next, this new node of the data should be saved, right? So for that, new node points to the data, and once we are set with this, we have now the new node points to the next, and it becomes to the head, right? So the new node points to the next of the new node, which becomes the head of the node. Finally, we have to assign the now the new node of the previous becomes the null once you add the address of the next node to the head of that node. So new node to the previous becomes null. Alright, so this is basically the algorithm of inserting at the beginning. So basically what we are doing is we are setting the pointer of the current head node to the pointer to the new node here. Alright, and then we have to set the next pointer of the new node to point to the current head here, this one, the current head of the node. And finally, we are setting a pointer, and finally we are setting a head pointer to the point to the new node here. So that is the code for inserting at the beginning of the linked list. So I hope you've understood this. Now you also have to check if the list is empty. So we have to set the head and tail pointers to the new node as well, right? So for that, the code would be if head equals to null, then head is equals to new node and tail is equals to new node. So this is basically the condition where if we are checking if the list is empty, then we have to set and tail, the head and tail pointers to the new node. Otherwise, we'll set the head pointer to the new node and update the old head nodes to the previous pointer. So I'm writing a else condition here, which says else head of previous becomes the new node. And head, we have to assign the head to the new node. So we are done with this. Now we are creating, let us now try to create a function or method to add a node at the end of the list here. Now if we are inserting at the end of the list, we need to traverse the list until we reach the last node. And then we have to set the next pointer of the last node to point to the new node. And then we have to set the previous pointer of the new node to point to the last node. So let's just see how it is being implemented, where you'll get a clear-cut idea on what we are trying to implement here. So let's just create a function, void insert, let's take insert at end as our function name, and I'm passing the argument data which stores the data value. So we are creating a new node and sets its data to be passed in that value. So basically node of new node is equals to new node. Now the code remains same, guys. So the new node here, new node of the data points to the data here is equals to data. Next, the new node of the next will point to the null. So new node to the next points to the null. And finally, the new node of the previous will become the tail value here, since we are inserting at the end. So the new node of previous is equals to tail. So also again, we have to check whether or not if the list is empty. So for that, the condition is again if the tail is here equals to null. There we have return head since we are inserting at the beginning. Now since this is at the end, we are checking for the tail value. So if tail is equals to null, so what we'll do is head becomes the new node and tail will become the new node as well. All right. So otherwise, we have to set the tail pointer to the new node and update the old tail node's next pointer. So the condition would be tail of next becomes the new node and we have to assign it to the tail. So tail becomes the new node here. So done with this. Alright, so I hope you've cleared with the insertion at the beginning and insertion at the end commands that we have written here. So let us now move ahead and write another function to add a node after a given node in the list. So that is what we are trying. Let's say if you want to insert a specific value or an element in between a particular node that is at a specific position. So the following code for that would be, so void, let's take the function name as insert at position. So I'm passing two values here, int key. So int key and int data are the two parameters that I have taken for the function insert at a specific position. So when it comes to inserting at a specific position, we have to traverse the list until we reach the node that comes before the desired position. So we have to first set the previous pointer of the new node to point to this node and set the pointer of the new node to point to the node that comes after the desired position that we want. And finally, we have to set the next pointer of the node that comes before the desired node position to point to the new node. So let us just see how it actually works here. So the code for that would be, so firstly we are creating a new node and sets its data to the has to be passed into the new value. So node new node value is set as the new node and new node of the data stores the value of data, will store the value in that particular node. So we have to find the node with the given key. That is what we have taken the parameter here, right? So we have to check if the node is with the given key or not that we are trying to insert at this specific location. So for that I'm taking node current location or the current position is equals to, if it is equals to head, while current location or the current position is not equals to null, and another condition is current points to the data which is not equals to the key value, right? Once we are done with this, we'll set the current value, which is current is equals to current of next. So the value points to the next of that node. So if the key was not found, we have to return the null value. So for that exemption also, we have to write the case. So the if condition would be if current is equals to null, then we have to return 0. All right. And also if the node with the key is the tail value, we have to set the tail pointer to the new node as well. So the code for that would be if the current is equals to tail, then the tail will become the new node here. Tail is equals to new node. So that's it. And next, once you are done with this, we have to update the pointers of the new node and the nodes around it. So since you are inserting at a specific position, the one to the previous of it and the after will also get affected. So for that, the code would be new node of the next will point to the is equals to the current of next, and new node of previous is equals to current. So the next will become the current and the previous will be set to the current value as well. And also we have to give a condition if current of next is not equals to null also. We have to give a case where current of next and the previous will become the new node. Alright, and then you have to set the current value. So the current of next will become the new node. So I hope you've clear with how to insert a particular element or a value at a specific node. Now we have to print all the values that we have listed, right? So we have to create a method to print the list. So I'm just taking another function, void, let's take print list, or you can take it any way of your choice. You can even now use display. So node is equals to head, while current is not equals to null. We are just checking whether the current value is equals to null or not. So if it is not equals to null, then print the value cout current of data. Alright, and initialize the current value. Current is equals to current of next. Cout and end the line. So that's it. Now we are done with all the operations. Now we have to implement the main method to add the values. So I'm just creating a main function here, int main, and inside that I am creating passing the parameter that we have taken at the beginning, so which was doubly linked list, and you can mention the list name as per your choice. Let's say let's take as DLL. Okay. So firstly, let us insert some elements in the beginning. So DLL dot pass the parameter that we have taken at the beginning, which is insert at beginning function. So we will try to add some values. Let's take 3, and similarly DLL dot insert at beginning 2. Similarly, we will take another value, insert at beginning 1. Alright, and then I'll use the display to show the values. So 1, 2, 3 will be the output which will be printed. So next, let us now insert some elements at the end of the list as well. So insert dot pass the function that we have taken, which is insert at end. So I'll be adding 4 and 5 are the two elements that would be added at the end of the list. And we will display the values again. Display DLL dot display. Now we will insert specific values at a certain position. So we will use DLL dot mention the function that we have taken to insert at a particular position, which is insert at position. Now you have to pass two parameters, that is the value and the position at which you want to insert. So I'm passing the value 6 and it should be inserted at the second node. Alright. Similarly, DLL dot insert at position let's take 7 comma 6. So the elements, the value of the data 7 will be inserted at the 6th position. And let's take a final one, which is insert at position 8 comma 8. Alright, and we will return the value. So I'm using DLL display again. Finally return 0. So that's it, guys. This is the code basically which we are performing to do some insertion operations and deletion operations at the end and the beginning and at a specific node of the doubly linked list. So I hope you've understood the code till now here. So let's just execute this and see the output. So as you can see in the output, firstly 1, 2, 3 are being displayed, which is the beginning of the list. And then we are inserting another 2 elements at the end, which is 4 and 5. So 4 and 5 are being inserted at the end. And then we are inserting 6, 7, 8 at a specific position. That is 6 at the 2nd position. As you can see, 6 is in the 2nd position. 7 at the 6th position. That is 1, 2, 3, 4, 5 and 6. 7 is inserted at the 6th position. And 8 is inserted at the 8th position. So in this way, we have to perform insertion and deletion on doubly linked list at various positions, like at the beginning, at a specific node, and at the end of the doubly linked list. And with that, we have pretty much covered everything about insertion and deletion operations in doubly linked list. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. We'll see you in the next video. Until next time, thank you and keep coding.